Welcome viewers. In this video we'll see the relationship between two port network parameter Z parameter in terms of H parameter. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Z parameter we are going to express in terms of H parameter. First we'll see what is Z parameter and what is H parameter. Z is parameter is called a open circuit impedance parameter. Either input and output port is open circuited. So the general format is equation or matrix format is V1 and V2 voltage matrix. 1 refers input port, 2 refers output port. Is expressed in terms of current I1 and I2, input port current and output port current. This is the impedance matrix. Z11, Z12, Z21, Z22. So the voltages are expressed in terms of current. One more parameter is there, Y parameter, that is short circuit admittance parameter. In that, current is expressed in terms of voltage. The mixing of these two is called a hybrid parameter, that is V1 and I2. Input port voltage and output port current are expressed in terms of input port current and output port voltage. So both are mixed together, so that's called a hybrid parameter. Voltage and current is expressed in terms of current and voltage. That's why it is called a hybrid parameter. So V1 and I2 is expressed in terms of I1 and V2. This is the hybrid parameter. H11, H12, H21, H22. Now we'll see these Z parameters one by one. What is these four parameters? Z11 is V1 by I1. By making I2 equal to 0, open circuited. For all four parameter, either input port or output port is open circuited. Here V by I is there, so it is a impedance. 1 refers input, so input impedance, open circuit input impedance. Z11 equal to I1 by V1 by I1 with I2 equal to 0. Now we'll go to the remaining parameters. Z21. V2 by I1 with I2 equal to 0. V by I. Here also V by I. So impedance. So output port voltage and input port current is there. So it is called a forward transfer impedance. Forward transfer impedance, that is open circuit forward transfer impedance because of both V2 and I1. Then Z12 is V1 by I2. Input port voltage and output port current. So here also impedance, V by I impedance. Input port and output port is there, so that reverse transfer impedance. So open circuit reverse transfer impedance. Here we are making the input port is open circuited, I1 equal to 0. First two parameter, output port is open circuited, remaining two input port is open circuited. Z22 is V2 by I2. So both are output port voltage and output port current 2, so that output impedance, open circuit output impedance with I1 equal to 0. Now we'll see the hybrid parameters. Similarly, we'll see the details about hybrid parameter. H11 is V1 by I1 with V2 equal to 0. V2 equal to 0 means short circuit. V by I, so impedance. Both are 1, so input impedance. Short circuit input impedance. H21, I2 by I1 with V2 equal to 0. So V2 is in a short circuit. So output current by input current. So forward current gain. Both are current, so it is called a current gain. Short circuit forward current gain. Then we'll see the remaining two. H21 is I2 by I1. That I already discussed. H12, V1 by V2. Here both are voltage. Input port voltage by output port voltage by I1 equal to 0. That is open circuited. First two parameters are circuited, now it is open circuited. V1 by V2, input by output, so that's reverse voltage gain. Then H22, I2 by V2. So I by V is there, so it is admittance. Both are 2, that refers output port. So output admittance, by making input port is open circuited. So open circuit output admittance. I2 by V2. Now we'll go to the how to transfer this impedance, how to find the relationship between Z parameter and H parameter. So the general equation of Z parameter is V1 equal to Z11 I1 plus Z12 I2. That is, take this equation number 1. V2 equal to Z21 I1 plus Z22 I2. Take this equation number 2. Voltage expressed in terms of current. Similarly, the general equation of H parameter is, here both voltage and current is available. Here also voltage and current is available. That's why we call H parameter. V1 equal to H11 I1 plus H12 V2. I2 equal to H21 I1 plus H22 V2. While writing matrix form, V1 I2 equal to H11, H12, H21, H22, the I1 V2. So this is the general matrix format. Now we'll see how to convert. So we take this equation 1, 2 as a Z parameter, 3, 4 H parameter. Now we'll see how to convert this. So first we'll take the equation number 4. We can rewrite the equation. So the equation 4 is I2 equal to H21 I1 plus H22 V2. Now we are going to brought this H21 I2 this side, left hand side. So while coming this side, it become negative. I2 minus H21 I1 equal to H22 V2. Now rearrange this. This term is written here. These two terms are written here in order to simplify. H22 V2 equal to minus H21 I1 plus I2. Right? Just it is rearranged. Now brought this H22 in the denominator of that side, right hand side. So we are brought this H22 in the denominator. So what happened? Minus H21 divided by H22 into I1 plus 1 divided by H22 into I2. This H22 is brought in the denominator. Now take this equation number 5. Now V2 expressed in terms of I1 and I2. Right. Now we'll take the substitute this value of V2 in the equation 3. We are going to substitute in equation 3. What is equation 3? This is equation 3. V1 equal to H11 I1 plus H12 V2. So this V2 we are going to replace with this equation. This value we are going to substitute here. Now we'll see how we are substituting. So here V2 we are substituting this value. This value is substituted here. Right, this V2 is replaced. Now we can multiply inside. What happened? V1 equal to H11 I1 plus minus. Here minus is there, so minus H12 into H21 divided by H22 into I1. H12 divided by H22 into I2. Right? This H12 is multiplied inside. So this is negative, this one positive. Right. Now we'll go for further simplification. So in this, I1 is commonly available between these two terms. We will take this I1 common. So that H11 minus H12, H21 divided by H22. This term is written as it is. We take the LCM of this H22, we will take this LCM. So we will taking LCM, what happened? We have to multiply. Here nothing is available. So we have to multiply this. So H11, H22 minus H12, H21 divided by H22. While taking LCM, it is well. This H11, H12, H22 minus H12, H21 is nothing but del H, determinant of the hybrid matrix. This can be written as del H. So finally what we got? V1 equal to del H divided by H22 I1 plus H12 divided by H22 into I2. Now voltage V1 is expressed in terms of current I1 and I2. Take this equation number 6. So we got the two equations, equation 5 and 6. So by comparing this equation 5 and 6 with 1 and 2, we can go for the relationship. Right. So this is equation 5, what we got earlier, and this equation number 6, what we got here. So here V1, V2, voltage expressed in terms of current. This equation 1 and 2, that is Z parameter is V1 equal to Z11 I1 plus Z12 I2. V2 equal to Z21 I1 plus Z22 I2. Now both are same. Here also V1 V2 is there. Here also V1 V2 is there. And that is expressed in terms of I1 and I2. Here also I1 and I2. So we can compare this coefficient. The coefficient of I1 is Z11. Here we have to refer this equation because here only we are having this V1. V1, V2. Here V2, V1 is there. So this V1, while referring, we need to compare equation 1 with equation 6. Equation 2 with equation 5. So because both are V2. So coefficient of I1 is Z11. Here coefficient of I1 is del H divided by H22. So we can write. So Z11 equal to del H divided by H22. Similarly, coefficient of I2 is Z22. Here coefficient of I2 is H12 divided by H22. So that we can write Z12 equal to H12 divided by H22. Now we'll compare this. No, they're not like that. Z12, right? Z12 coefficient of I2 is Z12, that is equal to this term, because we need to compare equation 1 and 5, right? So Z11 is equal to this term, Z12 is this term. Now we'll go to the equation 2 that will compare with equation 5. The coefficient of I1 is Z21. Here coefficient of I1 is minus H21 divided by H22. So that is written here. Z21 is minus H21 divided by H22. Similarly, the coefficient of Z22 is, here the coefficient of I2 is 1 by H22. So we can write Z22 equal to 1 divided by H22, right? So Z11 is equal to this term, Z12 is equal to this term, Z21 is equal to this term, Z22 is equal to this term. While comparing both, we are able to identify. Here equation 1 is compared with equation 6 because both are V1. Equation 2 is compared with equation 5 because both are V2. So finally we got this relationship. Now Z parameters are expressed in terms of H parameter, hybrid parameters. So in this video we discuss how we can express the Z parameters in terms of H parameter. First we discuss what is Z parameter, what is H parameter, then we'll go for the simplification. Finally we got the relationship. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. All the best for your examination.